In this video, I will discuss about parallel adder or cascading full adders. So in my previous lectures, already we have studied half adder and full adder. We know that in half adder, we can add two binary bits. That is, suppose one number is 1, another one is 0. So we can, with the help of half adder, we can add 1 with 0. It produces sum as 1 and carry as 0. If we add these two, we'll get sum as 1 and carry as 0. So as we know, in full adder we can add 3 binary bits. So in that case 1 0 1 can be added, that is 1 will be added with 0, it will produce the sum as 1. When 1 is added with 1, it produces sum as 0 and carry as 1. So in this case, this is sum and this is carry. So full adder is able to add 3 binary bits and half adder is able to add 2 binary bits. Suppose if we have 2 binary numbers, say A and B, where A is having 4 bits and B is having 4 bits. Let me assume A3, A2, A1 and A0 are 4 bits of A, and we have B3, B2, B1 and B0 are 4 bits of B. In that case, to add the content of A with B, only one full adder is not sufficient. So in that case, we are supposed to use cascading of full adders. Let me consider one example here. That is, I will consider the value of A as say 1 0 1 1 and value of B as say 1 0 0 1. So in this case, this is A0 bit, this is A1 bit, this is A2 bit, this is A3 bit. Similarly here we have, this is B3 bit, this is B2, this is B1 and this is B0. So here if we add these two numbers as we seen here, so first LSB will be added with LSB. So when 1 is added with 1, it produces result as 0 and produces carry as 1. So to perform these two operation, we need one half adder. Because we are adding 2 binary bits, we need one half adder. If we assume the initial carry as 0, in that case we can use one full adder to add 1 and 1, assuming that initial carry is 0. So here to perform this, I need one full adder. So now to perform addition of A1 with B1 along with carry, that is, it produces the value as 1 plus 1, that is 0. It produces carry again 1. So here to perform one addition of 1 0 1, we need one more full adder. Similarly, to perform this operation, we need one more full adder, and to perform this operation, we need one more full adder. So to perform this entire operation, to add A with B, we need 4 full adders. So in such cases, we have to connect those full adders in cascading form. So in that is nothing but a parallel adder. So let me finish up this. So 0 plus 0 plus 1 is 1. So here 1 plus 1 will be added. It will produce 1 0 as result and 1 as carry. So this final carry we will call it as C out. And here I can say that the LSB of the result I will call it as S0. This is S1, this is S2 and this is S3. S for sum, that is MSB bit of sum is 0, LSB bit of sum is 0. So here C out is the final carry out. Now let me represent the block diagram for this to add 4 binary bits. So now, as I said, first I need one full adder circuit. So here I should add A0 with B0. So input to this I will call it as full adder 1. So here the input is, one input is A0, another input is B0. So as we know, for carry full adder, I will assume the initial carry input is equal to 0, because while adding 1 plus 1, there is no carry. So I will assume carry as 0. For the first full adder, carry will be 0. So it produces two outputs. One is sum. So here the sum I will call it as S0. It produces S0 and it may produce the carry. I can call it as C1. So now this C1 will act as a carry input for the next full adder, because now to add A1 and B1 I should use one more full adder. Let me draw one more full adder here. So I should use one more full adder. I will call it as FA2. Here the inputs are, one input is B1, another input is, we have A1. So here the carry input, that is C in, is nothing but C1. So this acts as a carry input here, and again it produces two output. One output I will call it as S1 and another output is carry out. That is I can call it as C2. So now to add A2 with B2 along with carry, I need one more full adder. Let me draw one more full adder. So this is FA3. The inputs here are, one is B2, another one is A2. So here another carry input is nothing but carry output of previous stage. So this is connected here and it produces the output as ES2 and it produces another carry, I will call it as C3. So now to add MSB bits I should use one more full adder, that is FA4. Here the inputs are, one is B3, another input is A3. Here the carry input is carry output of previous stage and it produces the output as S3 and it produces the final carry, that I will call it as C out. So this is the block diagram of 4-bit parallel adder. So here we have cascaded 4 full adders. So the name is cascading full adders or parallel adder. This is 4-bit parallel adder. This is block diagram of 4-bit parallel adder. Four-bit parallel adder. Now by seeing this 4-bit parallel adder, I can draw the logic symbol for this. That is, so here we have, the carry input for this, that is Cin, and it has 4 inputs. Say this is 4 inputs of A value and 4 inputs of B value. So this is B input, that is we have B3, B2, B1, B0. Here we have A3, A2, A1 and A0. So as we seen here, it produces 4 outputs, that is we have S0, S1, we have S2 and we have S3, and it produces final carry out, that is C out. So it produces another output, that is C out. So this is logic symbol for 4-bit parallel adder. So integrated chip, the 4-bit parallel adder is available in the form of integrated chip. The number of that chip is 7483 or 74283. Integrated chip is available which performs 4-bit parallel adder or 4-bit parallel subtractor. Here I can write 4-bit adder. Now here we can observe that the disadvantage of this parallel adder is, so here when we concentrate on the first full adder, it will take the LSB bit of one number and LSB bit of another number. It will add these two and produces sum and produces carry. So this carry acts as carry input for the next stage. So this F2 stage will not generate sum and carry out until it receives from the previous stage. So there is a propagation delay while producing the result. So once it receives the C1 carry output of previous stage, it will add B1 with A1 along with the carry and produce the sum S1. In that case, FA3, that is third full adder, is idle. It will not produce the output S2 until it receives the carry from the previous stage. So in case of 4-bit parallel adder, the propagation delay will be more. So to avoid this propagation delay, we have another kind of adder known as carry look ahead adder. I will explain about carry look ahead adder in my next video. Thank you for watching.